Hello everybody. Today I can prepare for my similar triangles test by practicing the same way I prepare for every other math test. There's a lot of stuff in this unit. This is one of the few tests where you will not have any other old topics on it because there's so much in this unit that are all commonly asked Regents questions. Let's get to it. Triangle Sun has coordinates s0, 6. 0, 6 is S, U is 3, 5, N is 3, 0. It wants me to dilate by a factor of 2, centered at -1, 4. So to dilate, I count from the center to each point, and I do that the scale factor number of times. So I'm going to, let's start with S. To get from the center to S, it's right 1 up 2. I do that 2 times. So right 1 up to 1, right 1 up to 2. If there's a scale factor of 3, I will go up, right 1 up to a third time. But it's not, so I won't. That's going to be my S prime. Let's do U. U is 1, 2, 3, 4 right, 1 up. Do that twice. 1, 2, 3, 4, 1 up 1. 1, 2, 3, 4, 1 up 2. There's my U prime. N, 1, 2, 3, 4. 1, 2, 3, 4. Do that twice. 1, 2, 3, 4. 1, 2, 3, 4. That's 1. 1, 2, 3, 4. 1, 2, 3, 4. That's 2. That's N prime. Connect them. It should look correct. It should be similar to the original because that's the whole point of this lesson being in here, that similar triangles come from dilations. It looks good. It says to state the coordinates. So I guess we'll state the coordinates. S prime, U prime, N prime. We got 1, 8. We've got 7, 6. We've got N prime is 7, -4. We said there was a shortcut where you can multiply the coordinates by the scale factor. That's only if it's the origin. That should not be your go-to. Your go-to, count from the center to each point. Do that the scale factor number of times. You will have one of those on your exam. Number 3, I've got CD is 6.6, DE is 3.4, CE is 4.2, BC is 5.25. It wants AC. So when I have these twisted, rotated triangles, they're similar. All right, they're similar. They're not saying they're similar, but since those are parallel, we have alternate interior angles are congruent, which makes them similar. They're similar. For this picture, these twisted, rotated triangles, the corresponding sides are diagonal from each other. So 5.25 corresponds to 4.2, and X corresponds to 6.6. Nothing corresponds to the 3.4. That side is blank, so we're not using the 3.4 in this particular problem. From here, we cross multiply and solve. 4.2x equals 5.25 times 6.6. 5.25 times 6.6 is 34.65. Divide by 4.2. Divide by 4.2. X equals, use the calculator, of course, 8.25. So when you see this picture, these twisted, rotated triangles, the corresponding sides are the ones that are diagonal from each other, that are essentially on the same line. Which brings us to number 5. These are overlapping similar triangles. Well, when I see overlapping similar triangles, I can't see what corresponds to what, so I'm going to draw my own triangles. So I'm going to draw the big triangle like I see, exactly as I see it. And for the small triangle, I'm not going to draw it how it looks like there. I'm just going to draw a smaller version of the big triangle. Now, the tricky part is what letters correspond to what? Well, it says here that angle Y is congruent to angle O. So, O and Y correspond. In the picture, angle T is reflexive. So angle T and angle T correspond, and there's only one letter left in the original small triangle, and that's B. That's how we get the letters in the right spot. Now, I'm going to put the information into the original picture and into the new pictures. TY is 2, YR is 6, which means that TR is 8, TD is 4, TD is 4, it wants TO, I put an X. From here, I put my corresponding sides on top of each other, X goes over 2, 8 goes over 4, and I cross multiply and solve. 4x equals 16, x is 4. So when you see these overlapping similar triangles, draw the triangle separately, but draw the second triangle exactly as the big triangle, just a smaller version. The letters, it'll tell you one pair of angles that correspond. The other one will pretty much always be reflexive. And then from there, once you have 2, the third one is the only one that is left. Which brings us to midpoints. When I join the midpoints, 2 times the mid-segment is equal to the opposite side. That's the rule to use. A lot of little rules in this unit. I wouldn't say the lessons are hard. There's just a lot of little rules to know for each one, and there's a lot of lessons, so it's about practice. So if DE is 2x plus 11 and AC is 7x minus 1, 2 times the mid-segment equals the opposite side. 4x plus 22 equals 7x minus 1. And now I do the algebra. If you can't do the algebra, use the equation solver. 4x plus 22 equals 7x minus 1. Something's not right here. Did I make a mistake? Let's just keep on rolling with it. 2 times 2x plus 11 equals 7x minus 1. 23 equals 3x. I got 23 over 3. I guess this is just a flaw in the problem. I'm just going to leave it as 23 over 3. You won't get one that won't work out on your exam. AC, it's asking for. So AC is 7x minus 1. So it would be 7 times 23 over 3 minus 1. And whatever that gives you would be your answer. So I'm not concerned about it. It looks like I might have just made a little mistake when I set the problem, when I created the problem where it doesn't work out to a nice value. You won't have to worry about that on your exam. But the concept remains the same. 2 times the mid-segment equals the opposite side. Basically, once you get to this point, that's the geometry of it. From there, you just do the algebra, and your algebra will work out. All right, number 9, you need to recognize this picture. This picture is Hills-Sass. You need to just recognize the picture. It looks like a big mountain, looks like a big hill. When you see it, that's your Hills-Sass. It's asking for CD. You have to determine if it's Hills or Sass. To do that, is there an L involved or is there an A involved? In this case, there is an A involved, so I'm going to use Sass. And again, as far as this picture goes, this is H, L, L, S, S, altitude. So, S is 3 over A A is X equals A is X over the other seg. Now I don't quite have the other seg, expect to have to add or subtract pieces. Since this whole thing is 27 and this piece is 3, I subtract them and I get 24. Now I cross multiply and solve. I get x squared equals 3 times 24 is 72. I take the square root. Now it says to the nearest tenth. If it said radical form, I'd have to reduce the radical, but it doesn't. It says the nearest tenth. So I go to my calculator. I type in radical 72. I round to the nearest tenth. I get 8.5. Number 11, candy corn. Candy corn, bases separate. If there are no bases, put the top over top, the side over side, and the bottom over bottom. All right, what do we got going on here? Are the bases involved? No. So I put the top over the top, the side over the side, the bottom over the bottom. I'm not doing all three, I'm doing whichever two I have. Expect to have to add or subtract pieces. Since this whole thing is 10 and this is 8, this would have to be 2. Do I have both tops? Yes. I have 8 and 12, so top over top. Do I have both sides? I have 10 on the left. I don't really have this side. Do I have both bottoms? Yes. I have 2 and I have x. X counts as having it. The whole point is that x needs to be in the proportion. From there, I cross multiply and solve. 8x equals 24 divided by 8 divided by 8. X equals 3. So if the bases are not involved, put your top over your top, your side over your side, your bottom over your bottom. Expect to have to add or subtract. That's where the 2 came from. I subtracted the 10 and the 8, and then create your proportion from there. And then we got another candy corn. It's asking for from B to C. Candy corn, bases separate. The bases are involved, so separate the triangles. Try and draw them as accurately as you can. This is A, B, C. This is A, D, E. And now I'm going to transfer the information into these pictures. The small one's easier. AE is 230. DE is 120. BC is X. And AC is 230 plus 85, which is 315. Now, it's simple. I put my corresponding sides on top of each other. I've been doing that quite a bit already. X over 120 equals 315 over 230. Cross multiply and solve. 230x equals 120 times 315, 37,800. Divide by 230 to the nearest yard is 164. So if the bases are involved, separate the triangles. If the bases are not involved, put the top over top, the side over side, and the bottom over bottom. 15 and 16. We're revisiting Hillsass and candy corn. Why? Well, some algebra is going to come up. So the review sheet has one of each, which means you're going to see a straightforward Hillsass. You're going to see a straightforward candy corn without the bases, and a straightforward candy corn with the bases. Then you're going to see either a Hillsass or a candy corn where you have your Mr. X squared, where quadratics are involved. So If BD is 4, AD is x minus 6, CD is x. Well, I know this picture is Hill-Sess. There's an A involved, therefore it's Sess. S over A equals A over S. S, what's S? X minus 6 over A is 4 equals A is 4 over the other S, which is X. Now that I have my proportion, I cross multiply and solve. X times X minus 6 equals 4 times 4, which is 16. Distribute X squared minus 6X equals 16. Mr. X squared, he wants to party. All of his friends have to come over. X squared minus 6X minus 16 equals 0. Party time! Bubbles! We factor the trinomial. First sign comes down. Negative and a negative is a positive. I'm looking for two numbers that multiply to 16. If needed, we can do our calculator trick. We can go to y equals. We can do 16 divided by x. We can go to our table. I'm looking for two numbers that subtract to 6. I'm only looking at my positives, so 1 and 16 do not subtract to 6. 2 and 8 do. Bigger number goes first, equals 0. Set each factor equal to 0. Essentially, the sign ends up changing. I get x equals 8. I get x equals negative 2. Now, I can't have a negative length of a side of a triangle, so I reject the negative answer. I have x equals 8. The question is asking for CD, so make sure you substitute into the appropriate expression. CD is x, so CD is 8. If it asks for, let's say, AD, AD would be 8 minus 6, which is 2. It's not asking for that. It's asking for CD. The answer is 8. So again, you will see a problem where you're going to have to solve a quadratic equation. Do your Mr. X squared. I'm not going to tell you if it's going to be a Hill-Sess or a candy corn, but obviously, based on the earlier examples, you're expected to know how to do all those. Determining if a proportion is true. I do not like these pictures, so I'm going to get rid of them. I'm going to draw my own triangles. I'm going to draw my own A, E, C, and B, E, D. And to determine if a proportion is true, I am going to circle the letters horizontally and vertically. One direction should correspond. One should be in the same triangle. So let's start with CE and EB. CE, EB, they're not in the same triangle. They don't correspond. That's not correct. Choice 2, ECBE, ECBE. Is that the exact same thing we just did? Yes, it is. That's not correct. All right, let's go yellow. AE, AC. That's good. They're in the same triangle. Now let's go in the other direction. AE, BE. They correspond. That direction's good. That direction's good. That one looks good. And let's try the final choice. EDAC. EDAC. They're not in the same triangle. They don't correspond. It's not correct. The correct one is choice 3. Look horizontally, look vertically. One direction should correspond. One should be in the same triangle. And don't use this picture. Use the order of the letters that it's giving you. It's giving you AEC. So AEC is left top right. So BED is also left top right. And you go from there. Same thing, but in a Hill-Sess now. Well, if it's a Hill-Sess and it wants to know if the proportion is true, we need to see if it's Hills or Sess. If it's correctly substituted into Hills, then it's correct. If it's correctly substituted into SAS, then it's correct. If it's not, it's not. Pay very close attention to L1 and L2. If you're using the left leg, you need to use the left seg. And if you're using the right leg, you have to use the right seg. So I'm going to write L1, S1, L2, S2. I'm going to go through each choice. Choice 1, JL. JL is H over JK. JK is L1 equals JK is L1 over JM is S1. That one looks good. It says not true. That one looks good. Let's go to choice 2. JM is S1 over KM is A equals KM is A over ML is S2. That's SAS. Looks good. Choice 3. JL is H over KL. That's L2 equals KL. That's L2 over JM. That's S1. It's hills, but it's leg 2 and segment 1. That's not correct. So again, if I'm doing KL, if I'm using the right leg, I need the right seg, but it's giving me the left seg. That's not correct. Let's go through choice 4. ML is S2 over MK is A equals MK is A over MJ is S1. That's a correct SAS. They're all correct except for choice 3. Determine whether the following triangles are similar. Well, there's 3 methods. There's SSS, SAS, AA. The S's mean that sides are in proportion. The A means that angles are congruent. So, based on this information, the only possible one it could be is SSS, because all that they're giving me is 3 pairs of sides. So I have to see if they're in proportion by putting the corresponding sides on top of each other. 2 over 6, 4 over 8, 8 over 12. Use the calculator to reduce if you need to. You can just go alpha x two over 6 and it'll reduce it for you. There's 2 over 6. There's 4 over 8. There's 8 over 12. 1/3, 1/2, 2/3. Did they reduce to the same thing? No. Therefore, they are not in proportion. Therefore, are they similar? No. The sides are not in proportion. If it was side angle side, is this next one side angle side? Yes. AR is 15, RF is 12, OG is 8, DO is 10. ARF is congruent to DOG. The angle must be in between the 2 sides, which in this case it is. If it didn't give me that angle, if instead it gave me, let's say, this angle, then even if the sides were in proportion, I still wouldn't be able to say that the triangles were similar. We still have to determine if they're in proportion by doing what we did here, but just want you to make sure you understand that for SAS, the angle needs to be in between the 2 sides. Which brings us to... Did this thing freeze on me? I think so. Yes. Which brings us to number 23. It's asking for the scale factor. Well, you need to know that scale factor is image over original. This thing is still unfreezing on me. Scale factor is image over original. So the image is your primes. If the image is 18 and the original is 4.5, it's 18 over 4.5. Use a calculator if you need to. It's 4. Scale factor is image over original. What you need to know about perimeter and area with scale factor, you need to know that when you are doing perimeter, the scale factor is the same. But when you were doing area, you need to square the scale factor. So for perimeter, if the original perimeter is 10, I'm multiplying the perimeter by the scale factor. But for the area, I'm multiplying the area by the scale factor squared. For perimeter, I just multiply by the scale factor. For area, I multiply by the scale factor squared. 10 times 2 is 20. 12 times 2 squared. Use a calculator if you need to. It is 48. Finally, our proof. Let's hope I have enough time to do this, because if you see that clock in the bottom right, it's 12:20 and I got to be upstairs teaching in 5 minutes. Let's see what I can do. Period 7, I'm coming for you in 2024. When I see multiplication, I work backwards. SC times OU equals OT times SU. Multiply CPE. Cross products are equal. It's always the same exact last 3 steps when I am proving multiplication. You just need to practice it. Before the multiplication is always proportion. See assist tip. To make my proportion, I take what's being multiplied. They must be diagonal from each other, because I cross multiply things that are diagonal from each other. SCOU, OTSU. Before the proportion is always similar triangles. Triangle blank is similar to triangle blank, and the reason for that is always AA. Now I'm going to leave the letters blank for now, because it may not be obvious which letters correspond to which. I think it is obvious which triangles I'm proving similar here, because there is only 2 triangles that I see in the picture. So I start with the first given. Angle C is congruent to angle OTU. Given. So that's 1 pair of things congruent. To prove triangles similar, I need 2. I'm out of givens. I go on to my additional tools. VRIAS. VR is all we learned so far. I take that back. We learned them all. V, vertical angles? Nope. R, reflexive property? Yes. Angle U. So, angle U is congruent to angle U. Reflexive property. I needed to prove 2 pairs of angles congruent. That's what I always need to do for similar. I did that. So now I can state the triangles are similar, then the proportion, then the multiplication. I just need to fill in the letters for the triangles. Well, U and U correspond. So let's put U first for both of them. I know that C and T correspond. So let's put C and T next. C and T, and then just finish it off. UCS is the green triangle, and UTO is the small triangle. Work backwards when you see multiplication. That just needs to be practiced. It's literally always the same, just different letters. And then once you know what triangles you're proving similar, you start from the beginning and you find your 2 pairs of angles. I made it. I'm coming, period 7. You know exactly what's going to be on your exam. Practice it. It's a lot of little things. Most of it really isn't hard. It's just a matter of knowing how to do it. Practice it, and then practice some more, and then goodbye.